plugin developer environment PDE in Eclipse. Now we are focusing on plugin developer environment PDE. The plugin development environment PDE supplies tools that automate the creation, manipulation, debugging, and deployment of plugins. As an example, we are considering now PDE UI in plugin development environment. PDE UI provides editors, wizards, launchers, views, and other tools to create a full-featured environment to develop and deploy the Eclipse plugins, fragments, features, update sites, RCP products, and OSGI bundles. Some of the PDE tools includes form-based manifest editors, multi-page editors that centrally manage all manifest files of a plugin or feature, RCP tools, new project creation wizards, import wizard, export wizard, launchers, views, miscellaneous tools, conversion tools, integration with JDT. Now we are considering extension and extension points in concepts. Loose coupling in Eclipse is achieved partially through the mechanism of extensions and extension points. The basic rule for binding modular software systems is to avoid tight coupling between components. If components are tightly integrated, it becomes difficult to assemble the pieces into different configuration or to replace a component with a different implementation without causing a ripple of changes across the system. Choose coupling in Eclipse is achieved particularly through the mechanism of extension and extension points. The simplest metaphor for describing extension and extension point is electrical outlet. The outlet or socket is extension point. The plug or light bulb that connects to it is the extension. As with the electrical outlets, the extension points come in a wide variety of shapes and sizes. The only extension that are designed for particular extension point will fit. When a plugin wants to allow other plugins to extend or customize portions of its functionality, it will declare an extension point. Extension point declares contract typically a combination of XML markup and Java interfaces that extensions must conform to. Plugins that want to connect to that extension point must implement that contract in their extension. The key attribute is that the plugin is being extended knows nothing about the plugin that is connecting to the beyond the scope of that extension point contract. This allows plugin to build by different individual companies to interact seamlessly even without their knowing much about one another. Eclipse platform has many applications of extension and extension point concept. Some extensions are entirely declarative, that is, key attribute no code at all. For example, one extension point provides customized key bindings and another define custom file annotation called markers. Neither of these extension points require any code on behalf of the extension. Another category of extension point is for overriding the default behavior of the component. For example, Java development tools include the code formatter but also supply an extension point for the third-party code formatters to be plugged in. The resources plugin has an extension point that allows certain plugins to replace the implementation of basic file operations such as moving and deletion. Yet another category of extension point is used to group related elements in the user interface. For example, extension points for providing views, editors, and wizards to the UI allow base UI plugins to group common features such as putting all import wizard into a single dialog to define consistent way of representing UI contribution from a wide variety of other plugins. Now we are considering running the build in building an RCP application from a product configuration file in PDE built in tasks. When invoking Eclipse with this application to perform build, you need to set two arguments on the command line. Class ant runner entry point for running ant built inside Eclipse within the same JRE. Clients may instantiate that this class. It is not intended to be subclass. The package, this is in the package org.eclipse.ant core. The ant runner here. To run the build, you will use the org.eclipse.ant.core.ant runner. When invoking Eclipse with this application to perform a build, you need to set two arguments on the command line, dash build file, and this one. This is the path of the product build.xml provided by PDE build. It is located in the org.eclipse.pde.build/script/product build directory. This is the build file that drives the whole product build process. Here you can see dash dbuild etc. This is the file path to the build configuration folder. To run the ant run application using the following command. Now we are considering examples in API analysis and task in API tools and task in API tools. This task runs a complete API analysis of an API profile related to the baseline, including API use, binary compatibility, and bundle version number validation. The profile is the current state of the product under development. The profile is compared to an API baseline for binary compatibility, usually the previous release of a product. This will run the task creating report.xml files inside the folder D, then report, then XML. It will use the exclude list and the .api filters files located in D, then exclude list extension external .txt and D filters to reduce the number of problems to report. The problem severities will be generated by as specified by D, then test API, then org.eclipse.pd.api.tools.prefs. Since debug is enabled, some debug tracing will show up in the ant console. Now we are considering tips and tricks. The new spice in PDE. The following spice has been added and can be accessed by Windows, then spice, preference spy, bundle spy, context spy, CSS spy, CSS scratch pad, event spy, and model spy. Now this is the end of my presentation. Thank you very much for watching it.